Okay, hi. Last two sessions we have discussed about the surds. In the first session we have discussed definition of surd, types of surds. In the second session we have discussed about the pure and mixed surd. And in the third we are going to discuss now comparing the two surds. Comparing two or more surds, writing the surds in the ascending order and descending order. This is what we are going to discuss today. So let us start the session with recapitulation of what is surd. A surd is any number which is in the form of nth root a, where nth root a is not rational. That is, it should be irrational. Now we are going to convert, we have converted already pure surds to mixed surd to pure surd. Now today we are going to discuss how to compare the two or more surds. How can we compare two or more surds? So in order to compare the two surds, we need to learn first equiradical surds. What is the meaning of equiradical surds? What are these equiradical surds? Equiradical surds are the surds which is having the same order. If the order is same, then we are going to say that they are equiradical surds. Example, cube root 2 comma cube root 5. These two are called as equiradical surds because their orders are same. Here the order is 3, here the order is 3, that's it. What are equiradical surds? Very simple. If the orders are same, then those are called as equiradical surds. That's it. Nothing else. Check the orders. If they are same, they are called as equiradical surds. Done? So now let's continue with non-equiradical surds. What are non-equiradical surds? Very simple. If the orders are not same, that's it. Example for non-equiradical surds. Non-equiradical surds. What are non-equiradical surds? The surds whose orders are not same. Example, cube root 5, cube root 6, 4th root 5. What are the orders? Orders are different. So those are nothing but called as non-equiradical surds. Surds is otherwise called as radical. So that depends upon the order is most important. So equiradical surds are nothing but the surds having the same order. Non-equiradical surds are the surds which are having different orders. Now we will learn how to convert and how to compare two or more surds. For example, if we say any simple numbers like square root of 3, square root of 5. Square root of 5, square root of 3. You are going to compare them easily. You can say square root of 5 is greater than square root of 3 because 5 is greater than 3. 5 is greater than 3. Very simple. Okay, right? Square root of 5 is greater than square root of 3. Now you are able to compare these two very easily because both are square roots. Square root, square root. Their radicals are same. Their order is same. 2, 2. The orders are same. Then they are easy to compare. That means equiradical surds can be easily compared. We can easily compare the equiradical surds. So this is how it happens here. So now let's convert non-equiradical surds to equiradical surds. That means let us make the orders the same. If the orders are not same, we will make the orders the same. For example, cube root 2, 4th root 3. These are the two different surds. Okay, right? Here if you observe, the radicals are not same. That is, orders are not same. 3 and 4, the orders are different. That means they are non-equiradical surds. Now we need to convert them into equiradical surds. That means orders same. How to convert orders same? Simple way to do this one is, you need to take the LCM of 3 and 4. Orders LCM. Not the radicands. Don't take the LCM of radicands. This is important. You need to take the LCM of orders. LCM of orders is most important. What is the order here? 3. What is the order here? 4. What is the LCM of 3 and 4? Because they are whose GCD is 1, their GCD is 1. Directly we can multiply them. 3 times 4 is 12. So LCM is 12. Now because LCM is 12, now try to get here in this order place, whatever the order is there here. Now here in this particular place of order, you need to get this LCM value, that is 12. To get 12 here, the 3 should be multiplied with 3. We can multiply with 4. How much we need to multiply to get 12? 3 is there already. To get 12, we need to multiply with 4. So whatever the number I am multiplying here, inside we need to do it as power. You need to make it as power. So that they both will be. So now it becomes 12th root of 16. 12th root of 16. Similarly, the second one, this is 4th root. Even that also should be made as the same order. Order should be same. Here what is the order? 3 4s are 12. There also should be 4. Already 4 is there. 4 times 3. So we are multiplying with what? 3. So because we are multiplying with the number 3, inside we need to do power 3. So 3 is already there for this one, the power 3. Here 4 we are multiplying, so we are making as power 4. Here we are multiplying with 3, so here we are multiplying. So what is there, this one? 12th root of 3 cube is 27. Now observe the both of them. As the orders are same, they are equiradical sides. Now we can compare them. We can compare them. So first, in order to compare the two surds, we need to make them as equiradical surds. We need to convert them as equiradical surds. That is most important thing. So now these non-equiradicals, we made them as equiradicals, and then we can compare them here. 12th root 16 is less than 12th root 27 because 16 is less than 27. So what is this surd actually? This is that surd. This is this surd and this is this one. So you can write as cube root 2 is less than 4th root 3. This is how you compare 2 or more surds. First, we need to make them as orders same, that is equiradical sides, and then we need to compare them whether which is greater and which is smaller. Okay, I'll give you a small assignment for you. You can just write your answer in the comment box provided in this link. Which is greater? My question is, which is greater? Which is greater? Okay, right? 4th root 3 or square root 5? Square root 5. Which one is greater? Okay, right? Just solve it and put your answer in the comment box. Now, very next one, the questions will be asked like arrange the following surds in ascending or descending order. Ascending or descending order. So you need to know, okay, right? You need to know what type of order is this, ascending order, from which one to which one, whether small to big or big to small. That you need to know ascending order and descending order. Okay, so now he will be asking you to write the given surds in ascending order or descending order. How to do? So let us do with one small example. Let us compare square root of 2, cube root of 3, and fourth root of 4. Which among of the following of the three is greater, and which of the following is smaller, and how to arrange them in the ascending order? In order to compare, arrange, or descending order, first thing you need to know is whether they are equi-radical surds or not. That means whether their orders is same or not, you need to check. Now here the order is 2, here the order is 3, here the order is 4. So orders are different. So let us make the orders same. In order to make the orders same, the first foremost thing you need to do is, you know that one, we need to take LCM of the orders. What are the orders here? 2, 3 and 4. What is the LCM of 2, 3 and 4? Because all of them GCD is 1, so just multiply them, it will be 12. So LCM is 12. So now each and every order should be 12. Here the order should be 12, here the order should be 12, here the order should be 12. So what we have to do? Now the first one, here already 2 is there. 2 is already there because square root means 2. So in order to get here 12, we need to multiply with 6. Very good. Now this 2, we need to make it as 2 power 6. The next one, already here order is 3, so we need to get 12. In order to get, we need to multiply with 4. So multiply with 4. So whatever we are multiplying, we need to do inside the power. 3 power 4. The next one, fourth root of 4 is there here. To get 12, what we need to multiply? We need to multiply with 3. So 4 power 3. So now simplify. Here's the 12th root of 2 power 6 is 64. This is 12th root of 81, and this is 12th root of 64. So 12th root of 64. Now if you observe all the three, what are you noticing? Okay, right, you notice that these two are of same, and then this is, because 64, 64, compare the radicands, see the radicands, 64, 64, 81, these two are equal, and this is, so 12th root of 64 is the smallest one. Next 12th root of 64, these two are actually equal, and then 12th root of 81. So that is nothing but square root 2, fourth root 4, and next is cube root 3. This is your order. Okay, it's increasing order, so it is ascending order, we are increasing the values. So descending order is the reverse pattern. So cube root 3, the next fourth root 4, next square root of 2. This is how you write ascending or descending order. So this is how the comparison between the two surds or writing in the ascending or descending order of surds can be done. Thank you.